Hello, grade 11s, and doesn't it feel like quite a while since we've done this? Oh, I know, too long. Okay, so let's kick into it. We're going to be looking through our exam. So we're going to look at, here it is, and go through it. Remember, the idea is that we're going through and seeing how do we solve the questions. What do you have in your toolbox? No literal toolbox here. What do you have in your toolbox so that you can solve these? You see this question and you're going, oh, great. Question one, you get excited, right? Of course. So let's see how we're going to approach these. So we've got question one. Now remember, pause, go through the question, and then see how we might go about it. So we've got a straight line. Okay, great stuff. This thing looks like it's a straight line going through P, S, and T. So the first step that we're doing is just orientating ourselves with what we're given. So we're given a point P. It tells us that there's P, tells us about some point S, and there's T, and okay, so nothing too interesting that they tell us about the points, but that it goes through them. Come on, that was a little frustrating. So there's T. And it has an equation. Ooh, well, if it's got an equation, that already tells us quite a bit, doesn't it? So if there's our equation, y equals 2x plus 10, what's the gradient of this line? Cool, gradient is given to us by this bit here. So here we go, here's the gradient, m equals 2. And, well, straight lines, something that jumps out definitely to me is this plus 10. What does the plus 10 in the equation of the straight line tell us? Well, it tells us what the y value of the y-intercept is. So we already know that point there, well, we know it's 0 and 10, because that's kind of, well, it's almost like it's given to us. And for the other bits, well, P, we know something about it, and we know, what do we know about P? Well, we know its y value is 0, so therefore we could work out what the x value is. Okay, so there are two distinct ways that you can work out this x value. Well, there are quite a few. I want you to think of both ways, think of at least two ways how you might find the x value of point P. Two different ways. Okay, now remember, if you edpuzzling this, it's paused it for you and you had to write in your answer. If you're not edpuzzling, hit pause, because the idea is not just to watch this through and go, and I mean, already we've looked at a whole lot of stuff and we haven't even got to a question yet. We're just saying, oh, maybe we can find some interesting things. So for point P, the one way that I can think of is we know that the equation is y equals 2x plus 10, and we know that the y value is 0, so we can sub that in, and therefore we can solve our equation and get a value for x. Okay, great stuff. Another way that we might do it was to look at our gradient. So what is gradient? How do you define gradient? I think of gradient as rise over run. So we've got kind of how far along are we going? Maybe we can do it like that. No, that's not going to work, is it? So we got how far are we rising over how far along do we go? How that'll work. So if we know that this point is 0, 10, and we know our gradient is 2, it means that for every one step we go across, we must be going up by 2. So therefore, how many times do we go across by one step and up by 2? So making our little staircase, well, we're going up by 10, so how many lots of 2's do we have in 10? We've got 5 of them. So therefore, we can just say, well, this x value here is 5, and let's just put some sort of reason and say, well, because our gradient is 2, just to give a hint so it doesn't look like you just sucked 5 out of your thumb and, oh, that seemed like a reasonable answer. But if you've drawn something like this, or if you just talk about something here, just gradient, just something to say, I know what you did here. So remember that x isn't 5, x should indeed be negative 5 because it's down here. Okay, so either way is valid. I must say I like the beauty of this second way, and that's it. Okay, so we find out what that value is. Determine the coordinates of point T. Okay, so for point T, which bit of information that we haven't talked about is going to be crucial in finding out point T? Well, the thing that sticks out to me is that these two lines are equal. So it tells us here that PS is equal to ST. So that line is the same distance as that line. So there's not going to be a strict formula we're going to use here, or maybe you could think of one, but let's just think, well, if that one there, think of like when we work out parallelograms, and there might be a question later like that where, well, if that distance there is 5, what's that distance over there going to be? Well, surely it should be 5 as well. And if this distance here is, oh, not too halfway through the line. That was bizarre, right? That distance there must be 5. Looked way out of scale. So if that's 5, that's 5. So that must be 5 up there. And similarly, what's that distance there? And therefore, what is that distance there? Well, we've gone up by 10. So we must go up by 10 again. So we must go 10 plus 10. So it must be up by 20. And that is the question. I have no idea why I have so much space to work this all out, but maybe you're scribbling some of these ideas down. I hope you're not using distance formula and things like that. You could, but wow, that would take a while. Okay, determine the distance PT in simplest third form. Okay, if only we had a formula for distance. So the distance of PT. Well, you are kind of given this formula sheet. Any of these related to distance? Well, of course. So that one all the way in that top corner here, here's our distance. So just plug in your distance formula. D equals square root that squared plus that squared minus x value is minus, y value is minus, m is therefore that way. Determine the size of angle OST. Ooh, how do I work out OST? This angle like that. Interesting. I wonder what we need to do here. So let's move all of these, although maybe some triangles will help us. But let's see. So it's asking us, what's this OST? So that angle around there. What is, let's not call that theta actually. Let's just say, what is that angle? Ideas. Do you have something that's useful to find out how to relate angles to lines and gradients? Well, hopefully, in fact, I don't know if we give it, oh, we do too, look at that. There it is, gradient equals tan theta. Okay, so the gradient is tan theta. So in other words, this angle around here, we can work out, which is going to be the same. Imagine, let's just do this in another color. Say, well, that angle is going to be the same as that angle. Imagine like there's a corresponding angle. So that angle we can work out because from there we've got m equals tan theta. We know what m is, so we can work out what theta is. So that's theta over there. What's this angle over here? I'm really going to give it away. What's this angle over here? The rest of the angle? Well, it's 90 degrees. So all we have to do is say, I'm going to scribble it up here, 90 degrees plus, we're going to use this. So you're going to do some shift tan-y stuff, and you can get this angle here, and you just add it to 90, give it a go. If that's enough to get you going, great stuff. Give it a go, and then memo. Right, so what else do we need to do? And the diagram alongside. Oh, that was all we had to do. Oh, that's such a pity. We're really getting into that question. See, it's a pity when they're short questions, eh? Okay, so let's keep at it. In the diagram alongside. Remember, the whole point of this, and I'm going through it quite slowly, but you do need to spend a little bit of time getting into it. Now let me stop scrolling all around like a mad person. ODC. ODC is a right angle. Okay. In fact, it's a right angle triangle. ODC. O is the origin. Looks like it. Remember the origin, just it's going, that's 0, 0. C lies on the y-axis. Cool. It looks like it lies on the y-axis. So what do we know about point C? We know something straight away. Oh, we know its x value is 0. And this really, I can't encourage this enough. Scribble on your diagram as you're going, because no doubt we're going to use some of this information. D is the point minus 2, 4. Okay, cool. So there it is, and there it is. Determine the equation of the line OD. What's the general standard form of any straight line equation? I generally think it's mx plus c. What does c represent? C represents the y value of the y-intercept. So of OD, let's just scribble it in here. This line here, what can we clearly see the y-intercept is? Well, it's 0. So we know that it's just going to be y equals mx. Okay, how do we work out gradient? Well, I normally work it out. In fact, it's even on your formula sheet here, as if we need it. I mean, look, you even get given the equation of a straight line. Come now, we know that one. Okay, so we got mx, c is 0. M, let's just work out m. M equals rise over run, rise over run. Okay, so we're going from this point to this point maybe. So we're running, we're going across by 2. We're rising, or we're going down, so it's going to be negative. So we're going from 4 down to 0, minus 4, so our gradient's negative 2. So y equals minus 2x. Cool. I'm actually going to write this in here, y equals minus 2x. Maybe it'll be handy to have it on the diagram. Determine the equation of line DCB. DCB. Let's scribble it in another color here. Okay, DCB. We know quite a lot about this line. What do we know anything about a point that it goes through? Well, there it is, goes through D. Do we know anything about its gradient? It's a terrible leading question. Yes, of course we do. How do we know? Look at that. What do we know about the gradients of perpendicular lines? Well, kind of in two ways. Either times each other you get minus 1, or the one is just the negative reciprocal of the other. So this was y equals minus 2x. So this one here we know is y equals mx plus c. We don't know what c is, we'll have to figure that out. Y equals, well, if m is minus 2, take the negative reciprocal, so half x plus c. Cool. If we have that and we've got a point, how are we going to determine what the value of c is? We'll just sub this in. So we're going to sub it in. 4 equals a half minus 2 plus c. Solve minus 1 plus 1. C equals 5. Okay, so y equals a half x plus 5. I'm scribbling it here on the side of the picture. Yes, scribble on your diagram, but actually solve this out, this over here. I've just got it really zoomed in. So all of this working over here would definitely be much nicer if you put it, I wonder what it's going to do. It's going to select too much. But yeah, definitely put it down by the question, not all the way next to the diagram. Just easier to follow. Cool, so we sorted. That is it, question 1. Okay, well, that is a nice starting point. Really getting into this. Let's hit a circle in the next video.